So here's the recording with the rest of the examples from the Target 35 work packet, or note-taking guide. Like always, you should pause and try them first before I go through the answers. Number one. Notice we got e to some power. Usually that means our power is our u. U is cosine x. Du is negative sine x. The derivative of cosine is negative sine dx. Oops. So here we have u. Here we have du. The only thing we got to do is take care of the negative. And we'll do that by dividing both sides by the negative, or multiplying by negative 1. So we got negative e to the u du. Well, that very nicely works out to negative e to the u, which is cosine of x, plus c. All right, next one. Oh, this one's pretty straightforward. We have a negative up there. Well, let u equal that negative x. Du will equal negative dx. Everything matches up. We just need to move the negative over. So this is negative e to the u du. We'll throw our limits into this equation. So the 0 will go into there. Negative 0 is 0. The 1 will go into there. We'll get negative 1. We're not used to having the lower limit be larger, so I'm just going to switch the order. And remember, when I switch the order, that also switches the sign, so this negative goes to positive. So we got the antiderivative of eu du from negative 1 to 1. We'll integrate e to the u from negative 1 to 0. E to the 0 is 1. Anything to the 0 is 1. Minus e to the negative 1. You can leave it like that, or we got 1 minus 1 over e. All right. Here, got this here and that there. What you kind of notice is the 1. That's your wild card there. The derivative of 1 will go away because it's a constant. And then the derivative of the bottom becomes the top. So we let our u be 1 plus e to the x. So then du equals e to the x dx. Notice u is right here. E to the x dx is straight up for u, or straight up for du. So we got du over u. Take 0, put her in there. E to the 0, anything to the 0 is 1. 1 plus 1 is 2. Take our 1, put it in there. We got 1 plus e. And then we'll integrate. Antiderivative of du over u is natural log of the absolute value of u from 2 to 1 plus e. Plug those in, natural log. 1 is positive, e is positive, so I don't need the absolute value anymore. Minus natural log of 2. One thing, if this was multiple choice, your answer probably would not appear like that. They may take those 2 natural logs, and since it's a subtraction, write it as a natural log of 1 plus e over 2. Free response, either answer is fine. Excuse me. Just know that on a multiple choice test, they may not give you the first one you find. They may want you to be able to take it a little bit further. All right. Well, here we got e to the x inside cosine. Derivative of the e to the x is outside cosine. So We let the inside function be our u. U equals e to the x. Du equals e to the x dx. Straight up match. Du is right here. U is right here. So we got cosine of u du. I throw negative 1 in. E to the negative 1 is 1 over e. I throw 0 in. E to the 0 is 1. And then we'll integrate. Antiderivative of cosine is sine of u from 1 over e to 1. So we got the sine of 1 minus the sine of 1 over e. Alright. Now, this is just a little bit of review of when it's not e. Alright? When it's not e, it follows the same rules. So the antiderivative of 2 to the x is 2 to the x. But there's a different base. So we need to just divide by that new base. 2 to the x over natural log of 2 plus some unknown constant. So in conclusion, make sure you know the antiderivatives of each of the following. The antiderivative of e to the x, quite simply, is e to the x. Don't forget your constant. A lot of you on your daily quizzes are forgetting your constant. Alright, the antiderivative of 1 over x dx. Alright, a lot of you need to get familiar with seeing as dx over x or du over u. Basically, d something over something. And that is the natural log of the absolute value of whatever we got, x or u, plus a constant. And the antiderivative of a to the x, it's an exponential, so it's going to be the same, a to the x, but because our base is e, there needs to be an adjustment. Alright, that is all for today's video. Come tomorrow ready for target 36.